Hi, everybody. I'm Meredith Bernstein, an applications engineer here at Instron. Thanks for joining us today. We are going to deep dive into some advanced capabilities within Bluehill's TestProfiler module, specifically talking about the use of variables. This session is really intended to help all of you, so please feel free to throw any questions you have in the chat or any other interesting use cases that you think of, and we'll take a look at that toward the end of the session. So the goal today is really just to cover what are variables and how can we use them to optimize or enhance a TestProfiler method in Bluehill Universal. So let's jump right into Bluehill and we can take a look at that. Starting off, what are variables? So in coding, they're defined as a value that can change depending on conditions or information that is passed to the program. And it's really the same in Bluehill. You can think of it almost as a box that you label and you put something into, and then you can reference it and use it later on. We can also take a look at the help file and see how variables are defined within Bluehill. So these are typically accessed in a variable event, and the sort of boxes that we can utilize within a variable event are our sample number inputs, specimen number inputs, cycle count, total cycle count, or loop count. Quick plug for the help file. As always, if there's something that you need a definition for or you're looking for more information on, this is a really, really awesome resource that's built into Bluehill Universal. So we'll go through a few different examples of the different ways that we can use variables in a TestProfiler method in Bluehill. So the first one is using it as a counter. Bluehill has a built-in capability to do a loop count if you're looping between a couple of steps in a TestProfiler method. And similarly, if you're running a cyclic test where you're moving back and forth between a couple of different positions, Bluehill can automatically count that. What it doesn't have built in is the ability to count across multiple specimens, do a count at the sample level. Using variables, we are actually able to do that. Some of the cases where this might be really helpful are if you're testing something like a syringe or an auto-injector, where you might want to remind the operator to empty out that collection beaker after maybe 5 tests or 10 tests, something like that. So this way, you're counting how many tests you've run at the sample level, counting across multiple specimens that you've tested. Similarly, if you're testing some sort of medical device on maybe a manual XY translation stage, where you need to run a test in 5 different locations, let's say, and then after the 5, you're going to swap out the device, you can count, how many tests you've run, and then after 5 tests, tell the operator, okay, it's time to now swap out and test a new device. So let's see what this actually looks like in the software. So this is my start sample screen, and we see that we have this input called loop count. This is a sample number input, and I can change this to 5, 6, whatever we want to call it. And this is basically dictating after how many tests will I get some sort of notification to alert the operator to do something. So looking at the actual method itself, if I go into test control, and then this first step is called counter check. So this is sort of a decision-making step, if you will. The test isn't actually doing anything, but all it's looking at is as soon as this step gets entered, it is going to look at this sample counter variable, which is another sample number input. So you can see in sample number inputs, we have that loop count, which is the one that we wrote in on our initial screen, and then this sample counter, which is one of those variables that we're just using to reference. So if I go back to my test control, events and actions, step entry event, the first thing that it does is it sets my sample counter to the prior sample counter value plus 1. And this will remember that value across multiple tests. So the first time through, it'll say 1, and then it's going to make it 2, 3, etc. And then the other thing that this step does is it looks at that sample counter value and compares it to my loop count. So if the sample counter is higher than my loop count value, then you're going to get this operator alert that tells me empty the collection bin. The other thing it's going to do at that point is it is going to reset my sample counter value back to 1. So after you've run 5, it'll then start it back at 0, and it'll start that count over again. So simple as that. That's how we would do a counter using variables. The next thing that we want to cover is using variables to control the logical flow of a method. So you're running a basic tension test, and you just run single ramp, till failure, test ends, that's it. In TestProfiler, you have the ability to run, several steps in sequence, and then your test ends. What using variables to control the logic of the method means essentially is instead of just every time I run this method, it goes step A, step B, step C, I can actually tell it, you know what, in this case, only run step A, or only run step B, or only run steps B and C, for example. This is really, really helpful. Say you're testing something like a spring where you might want to run just a basic characteristic test on that spring. And then the next time you test it, you actually want to run a cyclic test where you're going to go back and forth between a couple of points. The advantage to doing this all in one method is then all of your results are also in one method. So instead of having to jump back and forth between a couple of different TestProfiler methods, you can do all of that in one place. Alternatively, you could have something like ISO 80369 that has a bunch of annexes. And again, you could have a test method that just jumps around to different sections of steps, each one corresponding to a specific annex to that test. So let's see what this looks like in Bluehill. So on my before test screen, which will show up before each specimen that I run, because this is something you might change between specimens, you'll see this control option drop down where I have ramp to hold or triangle waveform as my two options. This is a specimen choice input. So if I go into method, specimen, and then choice inputs, you'll see this control option drop down. And what this is doing is it's basically saying if I've picked triangle waveform, assign this control option specimen number input to 1, and then assign it to 2 if I've selected ramp to hold. And you can see here that those are my specimen number inputs, and it's grayed out because this only changes based on what I've picked from that drop-down list. So now if I go back into my test method, right after my counter check step, I have this control selection step, which is just another one of these sort of really quick holds that isn't doing anything. It's just making a decision, basically. So I go into events and actions, and you'll see these two events that are looking at whether it needs to move to the cyclic control section, which is my triangle waveform, or whether it needs to move to ramp and hold. And within each one of these, it's looking to see if the control option variable is equal to 1, it's going to then tell it, okay, move to my cyclic control step. The next one, ramp and hold, it's saying if my control option variable is equal to 2, actually we're going to jump ahead to my ramp to 50 newtons step. So you can see kind of from my control selection, I'm branching in multiple directions, essentially. I'm either going ahead to my cyclic control, or I'm jumping all the way ahead to my ramp to 50 newtons. And you could have a whole bunch of other options here. This could go to, have 5 different options, if you will, of different sections and different test procedures. Or you could have one that would have it move to cyclic control and then also to ramp to 50 newtons. This really is a very powerful way to build different capabilities into a single TestProfiler method, which really just helps keep things more streamlined and would keep all of those results in a common location in a common sample file for you. The last thing is using a variable to help define pass-fail criteria for a specimen. So the way this method is set up right now, we have our ramp to 50 newtons, and then basically across these 2 steps, it's going to hold 50 newtons for 1 minute. But we're using this initial hold step to identify if the specimen fails within the first 10 seconds of that hold. Because if it does, we don't really need to continue holding. We already know that it's failed and the test should end. So what we're doing is we're saying, okay, check for a drop in load. So this is a measurement event, which is another feature within your TestProfiler steps that you can use. So it's looking at your force measurement, and then it's comparing it to this hold failure criteria, which is another input that we actually can set back on the start sample screen. So you can type in whatever your criteria is here. So going back, load drop check, it's comparing to see if the force value at that point is below your failure criteria. And if it is, it's setting a variable that we've called device pass fail to 0. I now have a calculation that is looking at that variable, and it says, okay, if it's looking at this condition, pass-fail equal to 0, or equal to 1 rather. So if that condition is false, because my device pass-fail is equal to 0, and the specimen has not passed, then it'll indicate a failure as my result of this calculation. The default for device pass-fail is 1, meaning that it is higher than my failure criteria after the first 40 seconds, closer to 50 newtons still, in which case it's going to move on to my hold completion and continue holding for the rest of that minute. So those are a few ways that we can take advantage of variables to really create some pretty powerful and optimized test methods within TestProfiler. I'm going to go ahead and take a look at the chat, see if any questions came in. Give me 1 second here. Let's see. I'm not seeing anything, so I guess that means we've covered it all. But if you think of anything after the fact, please let us know. Don't hesitate to reach out. And I hope everybody learned something today. So thanks for watching.